Today's lesson is on polyatomic ionic compound nomenclature. In this naming system, we are going to learn how to name ionic compounds the same as we've done in the previous lessons, except for one of the ions that are participating in the bonding is actually called a polyatomic ion. And what that means is that it is made up of multiple atoms that behave as a single ion. In this particular lesson, we will first define what it is to be a polyatomic ion. Then I will show you where you can find examples of your polyatomic ions. And then we will move to the simulation and look at the formulas of some of these compounds from their names. And then we will just simply write the names from some of the formulas that are provided to us. All right, I am looking at an attachment that I have on my chemistry webpage. If you were to go to the first page of the chemistry site and scroll down to the bottom, you would find this attachment in the blue region. You also have this as a reference sheet on the back of your periodic table in class. What this paper is basically showing you is a variety of different ions and their charges that are associated with them that you might not necessarily find on the front of your periodic table. For example, cadmium, if you were to look for it on our periodic table, is not indicated as +2, so we've indicated that cadmium will be found as a +2 charge. Okay, cadmium is not polyatomic because it is only one atom. We also see manganese. I've also identified the different charges of some of the other guys. For example, we have iron, Roman numeral 2. Over here in the +3 region, I have iron +3. So we're just showing you some of the common guys. Now, you will also notice that in the +1 region here, we have one that looks a little bit different. There's two capital letters here. That means that there's two different atoms that are attached to make this +1 ion. And this guy is given a specific name as ammonium. Ammonium is actually a nitrogen bound to 4 hydrogens, but that still behaves like an ion and will still attract to negative ions. Now, more importantly than ammonium, we're going to look down to the bottom because there are so many more that are in the negative region. Okay, these are all atoms that are bound together and contain a negative charge. And if you notice, for example, acetate, we will see is made up of carbons, hydrogens, and oxygens in a certain ratio. And when they're together, they behave as a -1 ion. We also see a couple others. We have bicarbonate, for example. We have carbonate over here, chromate. We see phosphite here, sulfate, sulfite, nitrate, nitrite. Okay, if you've noticed, most of the guys that I'm saying here all end in ATE or ITE, and that's no coincidence. The ATE and the ITE ending indicate that all of these anions have oxygen in them in addition to some other elements. So we see nitrate, N and O. We see nitrite, N and O, but in different proportions. The O's actually, when they're in this form, are called oxyanions, meaning anions possessing oxygen. So when you see the name ATE or ITE, it indicates that it's polyatomic, as opposed to the IDE ending that you used in the previous lessons, indicating that it was just a single element that would bind to the cation. So we have a bunch of anions here, -1s, -2s, and -3s, and this is where we're going to find these. Now we're going to move over to the simulation, and we're going to work with these, and I'm not going to revisit this page today, but it's a good idea to have yours out as I do this. Okay, and I am back in Inkscape, and I am now looking at a couple of these ions, and we're going to show you how they go together. You will notice over here for my cation, I have Na with a +1. This is the regular sodium ion that you would find on the periodic table, so we would know it's a +1. We have copper. Now this copper is a specific case of copper because if you look, it has a 2+ charge, and we say copper has more than one identity. So we must realize that this is not just copper, but rather copper Roman numeral 2, indicating it has a +2 charge. And finally, we have aluminum with a 3+ charge, and aluminum is in group 3 of the periodic table, so it always has that 3 charge. So there's no reason for a Roman numeral for aluminum either. Okay, over here, these anions look a little bit different though. For example, we have OH with a minus charge. This is a grouping of O and H containing a total of 1 negative charge. We have SO3 with a 2-. This is sulfite. Sulfite is going to be SO3 with a -2. And we have phosphate, and phosphate has a -3 charge. Okay. Now, what we're going to do is if we put these together, everything is the same as before, except these guys have more than one symbol in them. So when we put them together, for example, if I took Na and I brought the OH together, we see that they fit just like the pieces of a puzzle like we did in the previous lesson. One Na was needed to bind with one OH. So this guy's name would be NaOH, meaning I needed one Na for one OH. This guy's name is sodium hydroxide. Okay, the two names are sodium is the Na and OH is hydroxide. I did not need to change any endings of any names. I didn't add any numbers. I just simply stated who the two ions were they got together. All right, now if I did the same thing with copper plus 2, this is copper Roman numeral 2. Copper Roman numeral 2, though, needs two negatives to actually satisfy it. So what we need to do is we bring over one OH, for example. And if we do this, we see that the Cu still needs another one. So just like before, we bring another OH in. And in order to make this compound complete, we would need two OHs to pair up with this copper. So this compound would be known as copper 2 hydroxide, meaning that you would need copper 2 and two hydroxides to form this compound. Now, if we counted them up, we used two OHs and only one copper. So this thing's formula would be CuOH2. Notice the parentheses that I drew. The parentheses indicate that I need two of these OH groupings. If the parentheses were left out, it would indicate that I needed a Cu, one O, and two H's, and it would be misleading, and whoever was reading this formula would read it incorrectly. So the parentheses are put there so that when you read it, you realize that the O and the H are meant to be together, and that you have more than one of them. Over here, I did not include the parentheses in sodium hydroxide because it is assumed that if there are no parentheses, we just have one of those guys. So this guy is NaOH, sodium hydroxide. This is copper 2 hydroxide. All right, and we will do one more example, and that would be if we were to use, let's say, copper 2 and phosphate. Now, if I were to use copper 2 and phosphate, what we see here is that I don't have enough coppers, so I need another copper, and I will bring it here. And just like before, now I have too many coppers but not enough phosphates, so I put another phosphate here. And then finally, I need another copper, so I'm going to steal this compound that we made before and put the copper over here. And we would see that we would fill in all of the gaps by having 3 coppers and 2 phosphates. So this guy's name would be copper 2 phosphate. The two ions that were participating were copper 2 and phosphate, but the ratios are that I needed 3 of the copper 2s with 2 phosphates. So the formula that we would use here would be Cu3PO42. Again, notice the parentheses are used here to indicate that I have 2 of those phosphate guys, and that is how we go about the naming. For the final part of our lesson, we're just going to show you how you write the names from formulas. And this is a pretty simple task. Sometimes it's a little bit more difficult when you have Roman numerals, but overall it's a pretty easy task to do. For example, if I look here, I see that I have Mg and I have OH, and we need to recognize that OH is one of those special groupings and that its name is hydroxide. But if you notice, it's very simple to name once I've identified that, because all you have to do is name the two ions that are involved. Mg is magnesium, so we call it magnesium, and OH, I have 2 of them, but it is OH, is hydroxide. And we just simply call this magnesium and hydroxide, meaning magnesium is paired with hydroxide. And based off of their charges, we should be able to go back and assume the formula if someone asks us what the formula was. So again, magnesium hydroxide. If we look here, we have a metal ion with a polyatomic ion. So we have 2 ions making it an ionic compound. And the name of these 2 ions that are participating are aluminum and sulfate. Notice I did not change any endings because the name is indicating that I'm talking about a polyatomic ion. So this is aluminum sulfate. Now, the one exception that you need to pay attention to, and I shouldn't even call it an exception, but the one thing that you have to think about a little bit is when you have metals that have varying charges, that rule still applies. So for example, this would be copper paired up with chromate. But we must remember that copper has 2 different charge possibilities. So because I have chromate, which actually had a -2 charge, and there are 2 coppers to cancel out the -2 charge, that each of these coppers must have had a +1 charge. So the 2 +1s canceled out the -2. So because it's identified as a +1 charge, this is copper Roman numeral 1, or copper type 1 chromate. So what we've shown you here is the basics of how you can write these names. Again, remember that you do not need to change the endings. You just need to look up the names of the ions, and that is it. Be sure to copy down the notes from my website and do the required quiz that goes with this section. and we will discuss this further in class.